Deep beneath the North Atlantic, nearly 300 meters below the surface, lies the RMS Titanic wreck, one of the most studied maritime sites in history. Discovered in 1985 by the Argo submersible, the Titanic wreck has been studied repeatedly, yet many structural details remained uncharted. In 2022, Magellan Ltd launched a new expedition with remote-operated vehicles Romeo and Juliet, equipped for high-resolution scanning.
Before reaching the wreck, sensors and cameras were precisely calibrated to ensure accurate data capture at extreme depth. The LOVs descended nearly 4 kilometers into the abyss, carefully approaching the wreck without disturbing the site. Over multiple dives, more than 7,000 high-resolution images were captured, providing the raw data for photogrammetry. Lasers and optical sensors measured distances precisely, creating millions of 3D data points for digital reconstruction. The enormous dataset, totaling approximately 16 terabytes, was carefully transferred to onboard servers for processing. Using photogrammetry, overlapping images were stitched together to create a detailed digital twin of the Titanic wreck. This digital twin allows researchers to examine the wreck in ways impossible with physical dives alone. The wreck's debris field has been meticulously mapped, providing insight into the ship's breakup and sinking mechanics.
Analysis of the hull shows how structural deformations contributed to the ship's fragmentation on impact. Comparing archival photos with the digital twin helps verify historical accounts and ship plans. Researchers highlight that the digital twin preserves detailed structures, supports archaeological interpretation, and allows ongoing monitoring of decay. Digital mapping of the Titanic represents a major advance in marine archaeology, offering lessons for submerged sites worldwide. The bow section of the Titanic shows extensive corrosion, highlighting the ongoing impact of deep-sea conditions. ROVs systematically scanned the debris field, capturing high-resolution data of boilers and engines for structural analysis. Photogrammetry allowed reconstruction of collapsed decks, creating a navigable 3D model for research. The grand staircase, once iconic, was imaged in detail, revealing structural damage and wooden remnants. Millions of overlapping images were processed and aligned to form the digital twin of the wreck. Laser scanning measured precise distances, enabling accurate mapping of hull deformations and surrounding debris. Cloud was carefully navigated the starboard side, minimizing disturbance while capturing detailed imagery. Cabin interiors were digitally reconstructed, revealing the layout and remnants of passenger quarters. Clusters of artifacts were mapped and cataloged, providing archaeological insights into cargo, personal belongings. Boiler collapse patterns help researchers understand the forces during the sinking event. Panoramic imaging provided spatial context for the bow and surrounding debris. Scientists validated digital models against physical measurements to ensure accuracy. The stern section reveals collapse patterns distinct from the bow, critical for understanding ship breakup.
Detailed imaging of deck plating and rivets informs structural integrity studies. The digital twin enables virtual exploration, offering insights that physical dives cannot provide. Cargo hold scans reveal the arrangement and preservation state of transported goods. Midship photogrammetry provides high-resolution models for research and preservation planning. RAW
crews document aft deck features, carefully recording structural collapse. Researchers annotate and measure features in digital twin for archaeological interpretation. Debris fields are digitally mapped to understand the spatial distribution of wreckage. Precise navigation ensures detailed imaging of confined and collapsed spaces. Point cloud analysis reveals subtle curvature changes critical for structural assessment. Staircase remnants are digitally reconstructed to preserve historical architectural details. Forward deck analysis shows how railing deformation correlates with debris impact. Port side imaging completes comprehensive mapping of the wreck's external features. Archival comparisons validate the digital twin and support historical accuracy.
Bulkhead mapping reveals internal structural integrity and collapse points. Detailed inspection of boiler tubes supports mechanical analysis of sinking forces. Engine room digital mapping preserves the spatial organization and mechanical design of Titanic. Cargo holds were scanned to understand how goods shifted and settled on the ocean floor. Hull breaches are analyzed to trace the sequence of structural failures. The digital twin captures bow, stern, midship, and debris fields in one navigable model. Detailed observations support ongoing archaeological research and preservation planning. With this detailed mapping, Titanic continues to teach us about maritime history and deep sea science. Starboard hull imaging shows corrosion patterns and metal fatigue crucial for structural analysis. Remnants of lifeboats provide insight into evacuation processes during the sinking. Midship deck collapse reconstruction highlights damage distribution from pressure and impact. Millions of images were merged into a cohesive 3D model for analysis. ROVs navigated tight debris corridors to capture inaccessible structural details. The grand staircase was reconstructed in detail, preserving architectural features digitally. Funnel collapse patterns help determine how structural failures propagated.
The boiler room layout was mapped to analyze mechanical arrangement and collapse effects.
Aft deck imaging shows debris arrangement and structural deformation. Stitching overlapping images ensures high-resolution accuracy. Portside hull scans reveal deformation patterns tied to the sinking sequence. Deck railings were digitally reconstructed to study mechanical failure.
Stern imaging captures spatial relationships between collapse and debris spread. Cabin reconstructions provide insight into passenger spaces and ship design. Cargo holds were mapped to analyze displacement and settlement patterns. Bulkhead mapping reveals internal structural integrity and collapse sequences. Boiler analysis helps explain forces acting during descent. Digital measurements reveal hull curvature and depth of admission.
Stern and propeller areas were reconstructed to document mechanical failures. Stairwells and adjacent areas were mapped to preserve architectural detail. Bow debris mapping clarifies structural failure sequences. Rivet and plating analysis reveals structural stress behavior. Forward deck imaging documents lifeboat structures and deployment damage. Collapsed cabin roofs were reconstructed to study damage patterns. Grand staircase mapping provides insight into passenger design diseases.
Hull crack imaging supports structural decay monitoring. Boiler room piping networks were reconstructed for mechanical analysis. Full wreck overview shows relationships between sections of debris. Aft deck imaging contextualizes debris placement and collapse. Deck railing models reveal damage propagation patterns. Port side imaging ensures complete external wreck coverage. High-resolution stitching merges thousands of images into one model. Engine room mapping preserves mechanical layouts for failure analysis.
Fracture mapping reveals structural weaknesses and collapse sequence. Debris accumulation patterns explain post-sinking settlement. Interior structures were documented to record collapse and preservation. Debris mapping reconstructs sinking dynamics and impact forces. Boiler scans reveal mechanical stresses during sinking. Propeller and stern imaging informs mechanical damage studies.
Passenger areas are reconstructed to preserve historical layouts.
Midship hull analysis supports preservation planning.
Port deck imaging documents structural integrity. Aft cargo holds were reconstructed for artifact study. Boiler degradation reveals long-term decay processes. Deck beam collapse analysis clarifies failure mechanisms. Roll Views map complex debris clusters in high detail. A complete wreck overview places all structures in context. Researchers identify points of interest using the digital twin. This comprehensive 3D mapping preserves Titanic for science and education.
Bow deck imaging reveals corrosion patterns and debris distributions. Starboard hull scans provide high-resolution reconstruction data. Midship deck collapse mapping shows deformation under pressure. Cabin interiors are reconstructed to study passenger spaces and decay. Lifeboat debris documentation supports evacuation analysis. Millions of images are stitched into a seamless 3D model. Stern and propeller reconstruction explains mechanical failure. As technology advances, these digital reconstructions ensure Titanic's story remains accessible to researchers and the public alike. Through this meticulous documentation, we honor both the ship and those who lost their lives, preserving history beneath the waves for generations to come.